everyone. I, Dr. Vivek Verma, Faculty Department of Statistics, Assam University, Silchar. Again welcome you all to our channel Statistics Hub. In our today's deliberation, we are going to talk about normality test and we'll also explore how it can be done in R. Okay, what is all about the normality distribution? As we all know that normal distribution is one of the recognized and utilized distribution in both theoretical and applied statistics, and is very much known in the name of that bell-shaped curve. It is characterized by two important parameters that provides its significance as well as a better understanding, which is mean, which is usually denoted as mean mu, and variance or standard deviation, which is usually denoted as sigma or sigma squared. The important aspect of the normal distribution is that its characteristics that makes it different from the other recognized distribution. The first and topmost, its symmetrical characteristics. Then, as we have discussed about bell-shaped, one of the important characteristics that uniquely identify a normal distribution is that its mean coincides with the median, which coincides with the mode. And one of the important more aspect is its unimodal characteristics that will always leaded by a single peak. The distribution helps in decision taking when we talk about its characteristics of the curve, which says that if there is a 1 HD, then the data which is enshrined within the normal distribution will cover around 68% of the data. Okay, whereas when its HD is deviated by the 2 HD, mean is deviated by 2 HD, then that will cover around 95% of the data points. And if it is deviated by 3 HD, then that will cover around 99.7% of the total data. Then the question of concern is there, why one should think about that normality test when we already aware about its characteristics, its utility and its recognizing tools. The beauty of that normal density is that it is not only confined within a distributional properties only, that has a lots of utility in the other aspects of the statistical analysis. First is the correlation, then regression, then one sample T, one sample decision taking procedure, that is the t-test, one sample t-test, two sample t-test, student t-test or pair t-test. The theory goes beyond when we talk about the multiple comparison using analysis of variance. The beauty of that normal density is that the tests which run around the entire procedure of the statistical analysis is based on one of the important assumptions that the variable that has been considered for all these analysis is normal variate. Then and only the properties and the characterization that has been defined under different analytical aspects can be properly utilized and explained. Then the question of concern is that when we know that the normal density is very important, then for the other analytical aspects including correlation, where we do the association or we search for the relationship, or we are thinking about the regression, we are going to formulate the relationship using an equation. When we are going to make our decisions in terms of comparison or in terms of accuracy with the population characteristics, or we are going to talk about the multiple comparison among the multiple characteristics or the variates, then normal density is going to play a significant role. The question that we should focus is that how one can test whether the data is following the normality assumption or not. There are two specific methods that is very much famous in the statistical literature. One is called visual inspection and another is called statistical test. Visual inspection are nothing but the graphical presentation of that normality, which is justifying whether the data is following the normal distribution and its characteristic or not. And the second part is called decisive methods, which is that they are going to test whether the data is following the same distributional pattern which is theoretically justified in terms of statistical test. Okay, then we should start with how the visual inspection can be possible. The first and topmost and easiest way is to plot the density of the data. If it is bell-shaped and looking like a symmetric curve with a unimodal peak, and its mean, median and modes are coinciding with one another, then one can say that the data is closer to the normal distribution. Another method which is very much available and do not require any package support in R is that QQ plot, which is also known as quantile plot. What we do here is that we draw the correlation between a given sample and the normal distribution. That is, here the normal distribution denotes the theoretical distribution. In order to check the coincidence among the theoretical and the sample distribution is that we draw a 45-degree line to check how good the data is following the normality theory. But many a times when we have a database of multiple variables, it's not always feasible to check each and every component in terms of its characteristics, its distributional pattern. Then we think about some statistical evidence-based methods that supports our claim the data is following the normality. There are two very known tests that is frequently used in the statistical literatures to draw the conclusion about the distributional characteristic, and both of them are the non-parametric methods, means the assumptions are not based on the behavior of the parameter. First of them is the Kolmogorov-Smirnov test. What it says, it started with an assumption in context of the normal distribution is that the null hypothesis is saying that the data is following near normality, whereas the alternative hypothesis, which is against the null, is saying that the data is not normal. It may be other than the normal distribution. The second test, which is frequently available in any kind of analysis, is called Shapiro-Wilk test. It says that how close the sample data fits to the theoretical normal distribution. The procedure, how one can execute these methods that we have discussed now using R. This is a R interface where I have demonstrated the first method of the visualization. Let us consider a sample of that has been generated within a range of -10 to +10, having a gap of 0.05, and if it is following a normal density curve, then how does it look like? Now one can see that one. If the data is following a normal density, then the curve looks like a bell-shaped one, have single peak and looking like a symmetric structure. If one will go with about its characterization, then under that situation, mean, median, mode all will coincide on a particular point. Now the another method that we have discussed about to cross-check how the quantile plot will look like in case of normal distribution. Here we have considered two different distributions. One is a sample that has been generated using a normal density. The command is rnorm of the sample size 2000, having mean 5 and standard deviation 1.5. Another database that is obtained from an exponential distribution of the same 2000 size, but its mean is 1/5. That is usually denoted as a rate of 5. Here we are going to check if the data is following a normal density, then how the QQ plot will look like. See, as we have discussed in our deliberation, that if the data is coincide with the normality distribution, then the sample will be closer to the 45-degree line, as we can see here. Then let's see how the situation will look like if the data is following a non-normal distribution. See, the deviation can be easily visualized which is specifically saying that the data is not following a normal density curve, and a significant deviation among the sample has been observed from the 45-degree angle. Now we are going to think about how the statistical methods can help us to obtain the test of the normality under the two different methods that were highly used, that is the Kolmogorov-Smirnov test and Shapiro-Wilk test under R. what we did here, that we have generated a sample of size 1000 having mean 2 and standard deviation 1.2, and we have assumed that the population only 0.5 deviated from the normal distribution. Let's check how the Kolmogorov-Smirnov test says. It says that the p-value is significantly less than 0.05. It says that the sample that has been observed through the normal, it may be possible they are normal but they are not closer to one another. Let's see how the distribution will look like if it is 0.2.5. Then the Kolmogorov-Smirnov test says that if the sample is closer to the population characteristics and the population is assumed to be the normal one, then both of them are cannot be considered as that significantly deviated. Then there is a less evidence to conclude that they are not normal. The another method that we have discussed here to check the normality is the Shapiro-Wilk test. As we have generated both the samples from the normal density, let's check how the Shapiro-Wilk test says that. The Shapiro-Wilk test says that the p-value is 0.2274, which is saying that the sample is following the normal density. And what about the population? Let's make it 2. It says that 0.7213, which concludes that if the data is following a normal density, then the Shapiro-Wilk test will have the capacity to make a clear perception based on the population characteristics with the sample characteristics to check the normality. The data sheet as well as the code that has been utilized for the demonstration has been shared with the video. If you found that video is helpful, informative and can help you for the further exploration, feel free to follow, subscribe and share our channel. Thank you everyone.